Hello and welcome to the 6-6 Notes. This is a section about trapezoids and kites. These are another two types of special parallelograms. So the first thing I want to do is talk about a trapezoid. And so I like to think of, it's a trapezoid from Star Wars. But a trapezoid, so a trapezoid, just a general trapezoid, okay, has exactly one pair of parallel sides, okay? And so I just want to quickly draw a picture of a trapezoid just to show you kind of what it is. Doesn't have to be perfect, okay? But the trapezoid, I know it's a trapezoid if all I'm given is one pair of parallel sides, okay? Now, what we would do here is we would call this segment here the leg of a trapezoid. This would be the leg of the trapezoid, and then this piece here would be a base, and this piece here would be a base, okay? So we have two segments that are bases. Those are the ones that are always parallel. And then we have what are called the legs of a trapezoid, okay? The other thing that we have is what's called the mid-segment formula, okay? So the mid-segment formula. Mid-segment formula. And what I'm going to do is I'm going to call this base A and this base B down here, okay? I'm going to call this has length A and this has length B, okay? If I were to come in here and draw a mid-segment, then that means that I'm going to cut the legs, to connect the midpoints of the legs, and I'm going to call that the mid-segment C, okay? And I know it's a mid-segment if both of these two segments are congruent. So what I can generate here is a formula, and the formula says that I can find C by taking 1/2 times the sum of segments A and B, okay? And this is really just an average of A and B to get C. Another way to write this would say C is equal to A plus B all divided by 2, okay? Same thing, but that's what we've got in an ordinary trapezoid. Now we have a special kind of trapezoid, and the special kind of trapezoid is called an isosceles trapezoid. So an isosceles, it's a trapezoid, okay? And an isosceles trapezoid has, one pair of parallel sides, okay, just like another trapezoid does, any trapezoid. The legs are congruent, okay? And then I know that the diagonals are congruent. And then I also know that the base angles are congruent. Okay, and I have two different pairs of base angles, two different pairs. Okay, and I want to draw a quick picture of what an isosceles trapezoid looks like. And so what I would have is a base like this, and then legs that come up that are congruent, that have the same angle. And I'm just sketching this, so it's not going to be perfect. Okay, and then I have my top base, okay? So I know it's a trapezoid if I've got one pair of parallel sides, so I would label these as parallel, okay? And then I know that my legs are congruent, so I'm going to come in here and put congruent symbols on my legs. I know that my diagonals are congruent, so I'm going to come in here and draw in my diagonals. Okay, from here into here. Okay, those are congruent. I know that my base angles are congruent, so let's write that. And I'm going to call this my base angle, and this my base angle. And then these two angles up here are also congruent. These are two different kinds of base angles, okay? And that's it. Okay, so that's what we have as far as a trapezoid goes. The last figure I want to talk about is a kite. And so a kite is another type of quadrilateral, a special type of quadrilateral. And so what I know about a kite, the properties that I have is that the diagonals are perpendicular, so the diagonals are perpendicular, okay? And then I know that only one pair of opposite angles are congruent, okay? And then I have two pairs of sides are congruent, okay, but they are not opposite, okay? So let me draw a picture of a kite so I can show you guys what's going on. And usually how I draw a kite is I first start to make kind of like a sideways cross. You can make a vertical cross if you want. But I make a segment that goes like this, and then a perpendicular segment like that, okay? And so what I get from this is a four-sided figure if I connect all the endpoints like so. Okay, and that gives me a kite. First thing I know is that the diagonals are perpendicular, okay? I know that only one pair of opposite angles are congruent, and it's always these two pairs, or this pair, okay? And then I know that two pairs of sides are congruent, but they're not opposite. So what I would do is I'd come in here and say that these two segments are congruent and that these segments are congruent, okay? We could also say that only one diagonal is bisected. So we can say that, that one diagonal is bisected, okay? And that's this one right here. It's this one in the middle, okay? So we've got all those different things, okay? We could also say that one diagonal is an angle bisector, okay? So let's say that. One diagonal is an angle bisector. All right, so I'm going to come in here. I'm actually going to zoom in on this picture and call this angle, these two angles are congruent, and then these two angles are congruent. All right, so kind of an interesting figure here, you know, kites and trapezoids. So you'll see them, you know, on your homework and stuff, but let's go ahead and answer some questions about this. So let's take a look at number one. It says it wants us to find each measure. So what I know is that, you know, this is an isosceles trapezoid. Okay, I know that QT is 14. I know that RS is 14. So I know that these two segments are congruent. And it wants me to find what angle S is, okay? And so I'm going to go ahead and call angle R. I know that these two angles are congruent. So this is 63 degrees, okay? But it wants me to find out what angle S is. That's what I'm concerned with. Now, here's the thing. What I'm going to do here is I know that my, if I were to extend these two lines out and extend out RS, that I have two parallel lines cut by a transversal, so two parallel lines cut by a transversal. And what I know is that these two angles here are consecutive interior angles, which are supplementary. So I would say this. I would say that angle S plus 63 is equal to 180. Okay? So if I subtract 63 from both sides, then I get that angle S is equal to 117 degrees. Okay? So I just need to kind of use what I already know, use some logic, and answer the question. Okay? Let's take a look at number 2. It wants me to find what angle D is. Now, because this is a kite, I know that angle D and angle B are congruent. So I can just call each of those x. You can do this a number of ways. But I know that the sum of all these angles in here is going to add up to 360, okay, because I have 4 angles. So here's how I could set up that equation. I could say 2x, because I have 2 of them, okay, plus 36 plus 70 is equal to 360, okay? So 36 plus 70, that's 106, so I get 2x plus 106 is equal to 360. Okay, so I'm going to subtract 106 from both sides. And so we end up getting that 2x is equal to 360 minus 106 is 254. Okay, and if I divide that by 2, then I get 127. Okay, so x is equal to 127. So angle D, all right, let's answer the question. Angle D is equal to 127 degrees. Okay, so that's what I got for those. All right, so now let's go ahead over here, and it wants us to figure out, all right, some of the side lengths on a trapezoid, given that T and S here are midpoints. Oh dear. Okay, given that T and S are midpoints. So what that does is that cuts this figure like that. All right, and it follows the mid-segment formula. Okay, so I'm going to call this A, B, and mid-segment C. Okay, and remember our formula for the mid-segment is that C is equal to 1/2 times A plus B, or we could say that C is equal to A plus B all divided by 2, okay? So, it tells us in the first one that HJ is 14, okay, and that LK is 42. We need to find TS, all right? So we're given A, we're given B, we need to find C. So what I'm going to do is come in here and plug that into my formula and say that segment length TS is equal to 1/2 times the sum of 14 and 42. So 14 and 42 add together to get 56. So TS is equal to 1/2 times 56. And if I take half of 56, then I get that TS, that segment is equal to 28, okay, and that's my answer. All right, segment TS, all right. So then the other one is that they give you, in number 4, they give you the segment HJ, okay, is 7. They give you that TS is 10. They want you to find LK. They want you to work backwards. So let's go ahead and answer that question. And what I'd want to do is I know that HJ is A, segment A. This is segment C, and this is segment B. All right. So I know that 10 is equal to 1/2 times 7 plus side length B, which is LK. Okay. And so if I'm multiplying by 1/2 or dividing by 2, I could move that over by multiplying both sides by 2. Okay, so those divide out, and we end up getting the equation that 20 is equal to 7 plus B. I'm going to subtract 7 from both sides, and so B is equal to 13. Okay, so I can then conclude that LK segment LK is equal to 13. Okay, so that's using the mid-segment formula. Okay, I'm going to go ahead and stop the video, and then I'm going to do another one with 5, 6, and 7. So I hope you enjoyed this, and we'll see you soon. Thanks. Bye.